What's up, YouTubers and fellow riders? The Chemist is back at it again. Today I'm going to be showing you how to modify your LED headlight that's currently working in low beam mode and make it function in constant high beam mode with a few simple modifications. So stay tuned. Okay guys, so I recently ran into an issue where I noticed my front LED headlight was flickering every time I hit a bump in the road. Not knowing which bulb was the issue, I began by inspecting each one, and when I got to the projector bulb, I noticed that only one side of the LED panel was working, which was correct by the way. But when I applied a twisting motion to the LED cabling, I was able to make the second LED panel light up, which indicated that I had a short and thus was the cause of my flickering issue. Okay, so problem solved and there's nothing left to do but correct the wiring issue, right? Wrong. At this point, now that I have uncovered that only half of the projector lamp is working by design, I wasn't satisfied with the idea that my lamp was only producing half of the amount of total lumens or light that the LED system is capable of. I mean, correct me if I'm wrong, but isn't the main takeaway of having a high emitting LED lamp is to see further down the road? Well, you can't do that correctly, only illuminating half of the light source, right? Well, with that said, I wanted to modify the LED wiring and make it work in constant high beam mode without having to modify any of the bike's wiring harness or create all sorts of extra pigtails and jump connections that you typically see in some cheap aftermarket HID kits. But enough with the babbling, let's get to the build. What you see here is my aftermarket LED light that I purchased off of Amazon a few years back. For those of you interested in purchasing a similar style lamp, I'll post a link in the description section of this video. I highly recommend these LED lights over conventional halogen or any HID kit on the market. Most if not all of these LED style lights operate in the same fashion, with some slight differences in design feature such as external drivers, removable heat sinks, fans, or what have you. The inner workings of these lamps all typically remain the same, consisting of the use of a pre-printed circuit board to mount the LED chips to, and provide separate power connections to each of the two halves for the high and low beam function. One quick note on the word usage of high beam while we're on the topic. High beam does not mean that one side of the panel has a light that is brighter than the other side. No. When we talk about high beam, we're merely talking about switching or powering on a second lamp through the use of our controls. The second panel, when activated, provides an additional light source on the opposing side, giving us a true 360-degree field of light within the housing rather than using the chrome deflector to do the job for us. This rabbit hole goes deep, far beyond the scope of this video, so let's keep the project simple and get back on topic. I first began by removing the 4 small screws that held the pre-printed circuit board in place and gently slid out both PCBs to expose the wiring within. The side with the yellow and white wire is my normal headlight function, while the opposing side with the red and black wiring is my secondary light, or soon to be high beam. Since the wiring on my 05 750 does not allow me to control the secondary light function of this bulb, I needed to find a way to manually wire this side up to have the bulb function in full high beam mode. Rather than cutting into the exterior cable sheathing, I chose this route as it is often difficult splicing and reconnecting thin gauge wiring, and also I didn't want to have a weak point in my protective sheathing susceptible to the elements. Using a soldering iron, I removed the red and black wires from the circuit board and trimmed back the cabling, as we will no longer be using this power source. It's important to note that even though this power source is not active, we still don't want any exposed wiring coming in contact with the aluminum housing that could potentially cause a short, or worse, a fire. So take extra precaution when trimming your cabling to ensure no wire is exposed before tucking it back in the light housing. Using a thin gauge wiring, similar to the cabling of the headlight, I soldered in 2 new leads onto the circuit board with some added extra length. To ensure your welds are good and secure, when you are finished, give them a slight tug and make sure none break free. We don't want these wires coming free while sitting in the aluminum housing, which could result in a potential fire. Once I was finished, I trimmed back any extra exposed wiring not covered by my solder work. Now that we have our new wiring in place, I slid the new cabling of the second LED panel to the opposing side and cut the wire to my desired length. Here is where we'll be soldering in our respective power sources, positive to positive and negative to negative. Once I was finished with my soldering, I tucked my wires back into the light housing and made sure none of my wiring and solder welds came in contact with the light housing, and followed up by reinstalling the circuit board screws. Once the light modification was finished, I gave it one final test with successful results, thus bringing this DIY project to a close. I hope you enjoyed this video tutorial on how to modify your LED headlight to work in constant high beam mode if your bike or car's wiring doesn't allow you to control this function. If you like this video, don't forget to give it a thumbs up, and if you haven't done so already, don't forget to subscribe. I'm the Chemist, and I'll see you next problem.